Here is a level 2 type question. An opaque paper bag contains 8 balls, 1 to 8. 4 balls are drawn without replacement. You're taking one out, you're noting down its number, but you're not putting it back in the bag. What is the probability of drawing 6, then 7, then 4, then 5? The probability of getting 6, well, that's just 1 ball out of 8. And then for the 7, it's now 1 ball out of 7. And then for the 4, you got 1 ball out of 6, and for the 5, 1 ball out of 5. All right, so the basic counting principle tells us that the number of outcomes for the first ball is, well, we've got 8 balls, but then you only have 7, so there's only 7 possible outcomes, and we can multiply these times 6 times 5. 5 times 8 is 40, and 7 times 6 is 42. 40 times 40 is 160, and 2 times 40 is 80 is 1,680, like that. Now this is just one outcome out of that. So the probability of rolling a 6, then 7, then 4, then 5 is 1 out of 1,680. All right, let's give that a shot. 1 out of 1,680. And then let's check to see if we're right. Yay! Here's another question. You have 6 hats, 2 shirts, 1 pair of pants. Given that an outfit must contain 1 hat, 1 shirt, 1 pair of pants, what's the probability of randomly choosing an outfit with an olive hat, orange shirt, and red pair of pants? Basic counting principle tells us we've got 6 of these. So 6 hats times 2 shirts times the 1 pair of pants. So we're going to have 6 times 2 times 1. That's 12 outfits. And this is just 1 outfit out of the 12. 1 out of 12. You can write that as a fraction. You can write it as a decimal or a percent. But if you're writing as a decimal or a percent, round it to 5 decimal places. 2 dice are rolled. What's the probability of rolling a 4 and a 1? This is just 1 outcome out of 6, and here you have 6, so 6 times 6, 36 different outcomes altogether. All right, so the basic counting principle tells us the number of ways of rolling the first die times the number of ways of rolling the second die is 36 ways altogether. And this is just 1 outcome out of the 36. 1 out of 36. A spinner with 9 names: Ona, Simona, Catherine, Kiana, Uma, Megan, Alexia, Lola, Ellen is spun. And then another spinner with 8 colors: red, orange, yellow, olive, green, teal, cyan, and blue is spun. And then another spinner with 11 letters: A, B, C, D, E, F, G, H, I, J, K is spun. And then yet another spinner with 9 foods: egg, butter, yogurt, sandwich, bread, pizza, fish, waffles, toast is spun. What is the probability of spinning the outcome Simona, orange, E, yogurt? So the basic counting principle tells us that we've got 9 here, and times 8 times 11 letters times 9 foods. 9 times 8 times 11 times 9 is 7,128. And this is going to be 1 outcome out of that. 1 out of 7,128. So it's 1 out of that. Yay! There are 2 routes between Rivière-du-Loup and Quebec, A and B. 6 routes between Quebec and Trois-Rivières, C, D, E, F, G, H. I've got to go, actually. Here's a level 2 type question. 5 dice are rolled. What is the probability of rolling a 2, 3, 1, 6, and 6 in that order? So the basic counting principle tells us that if you have 6 ways of getting the first outcome, and 6 ways of getting the second outcome, and 6 ways of getting the third, and 6 ways of getting the fourth, and 6 ways of getting the fifth, then the total number of ways of getting an outcome is 6 times 6 times 6 times 6 times 6. 6 times 6 times 6 times 6 times 6, or that's 6 to the power of, there's 5 dice, 5. Handy dandy calculator. 6 to the power of 5 is 7,776. So we're looking at the probability of getting this 1 outcome. That's 1 outcome out of 7,776. The probability of getting that 2, 3, 1, 6, and 6 is 1 out of. You can write that as a fraction or as a decimal, rounded to 5 decimal places, or a percent rounded to 5 decimal places. I'm going to 1 divided by that number gives us, as a decimal, it is 0.0001286. I'm just going to multiply that by 100 to make it into a percent. All right, so it's 0.01286%. That's pretty small. I'm going to round it to like 4 or 5 decimal places, the percent symbol. 2 coins are flipped, and then 3 dice are rolled. What's the probability of obtaining tails? then heads, then 3, then 3, then 6. There are 2 outcomes for the first coin, times 2 outcomes for the second coin, it's only heads or tails, times 6 outcomes for the first die, times 6 outcomes for the second die, times 6 outcomes for the third die. We have 4 times 216, so that is 864. The probability of getting this is going to be 1 out of, because it's 1 outcome, out of 864 equally likely outcomes. 1 out of 864. Five coins are tossed. What's the probability of rolling heads, tails, heads, heads, heads? There are 2 outcomes on the first coin, times 2 outcomes on the second coin, times 2 outcomes on the third coin, times 2 outcomes on the fourth coin, times 2 outcomes on the fifth coin, which makes 2 to the power of 5, if you like, which is 32. So the probability of getting that is going to be 1 out of 32. I'm just going to write that as a decimal this time. 1 out of, or divided by, 32 is 0.03125, or 3.125%. All right, so I'm just going to write that as a decimal. We have a die and then a spinner. A die is rolled and then a spinner with 3 colors, red, orange, or yellow, is spun. What is the probability of drawing 6 orange? For the die, we have 6 possible outcomes. For the spinner, we have 3 possible outcomes. In total, there are 6 times 3, 18 possible outcomes. The probability of getting 6 orange is just going to be 1 out of 18. 1 outcome out of 18. 1 out of 18. There are 4 trains between Windsor and Barrie. Between Windsor and Barrie, there's A, B, C, D. There are 4 trains between Barrie and Sudbury, trains E, F, G, and H, and 2 trains between Sudbury and Sault Ste. Marie, I and J. What's the probability of choosing trains A, then F, and then J? The probability of drawing A, then F, and then J. That's going to be 1 outcome out of the total number of outcomes. Let's figure out the total number of outcomes. So we have 4 choices for the first train times 4 choices for the second train times 2 choices for the third train. So that's 4 times 4 times 2 is going to be 16 times 2 is 32. So there are 32 possible outcomes. That's the basic counting principle. There are 4 ways to do the first step and 4 ways to do the second step and 2 ways to do the last step. Then it's 4 times 4 times 2 different ways. It's 1 out of 32. I'm going to do this one as a percent. 1 out of 32. I'm just multiply that by 100. And so that's 3.125%. Like that. Yay. All right, that's it for level 2. Have a good day.